Hey all, Mr. P back on another snowy day to talk about our next unit, which is called logic. So we're going to start our unit with talking about some statements we call conditional statements. So first things first, a conditional statement is written in the form if-then. We say if-then form. So here's an example. If an animal is a bird, then it has feathers. So there's some sort of condition attached here. We know if an animal is a bird, then it's going to have feathers. So this part here in red is what we call the hypothesis. An if-then statement is going to have two parts. It's going to have the hypothesis, which is just the words after the word if. So if is not included in the hypothesis. We also have a second part called the conclusion. So this part in blue, the words that come after the word then, that's the conclusion. So the hypothesis is an animal is a bird. The conclusion is it has feathers. The if and the then are just the words that make this thing a conditional. When we talk about conditional statements, we sometimes write them in symbols. The symbol we usually give to a hypothesis is the letter P. The symbol we usually give to the conclusion is the letter Q. And then to make this look like an if-then statement, the symbol we use is an arrow to the right. So this kind of is read, if P, then Q. Okay, so again, if P, then Q. Another way we say this is P implies Q. But it's easy enough just to say if P, then Q. And again, P represents the hypothesis, which in this case is an animal is a bird. Q represents the conclusion, it has feathers. So it's important to be able to find the hypothesis and the conclusion to be able to determine the difference between those. So let's do that now. We're going to underline the hypothesis and circle the conclusion. So the hypothesis is the stuff that comes after the word if and before the word then. So the hypothesis of this statement is two angles are a linear pair. The conclusion is all the stuff or all the words that come after the word then. So they are supplementary is our conclusion. So that's our Q. What we would represent with P if we were doing this in symbolic form is the hypothesis again. Two angles are a linear pair. Sorry about that. Similarly here, we have another if-then conditional statement. Our hypothesis, again, the stuff that comes after the word if and before the word then. A dog goes to daycare. That's our P. And our conclusion is the stuff that comes after the word then. It is a happy dog. And that's Q. And I would say that's a true statement because Murray went to daycare and he's certainly a happy dog. So sometimes we'll get a statement that is a conditional, but it's not in if-then form, and we can rewrite it in if-then form using a hypothesis and a conclusion. And this is something that sort of takes practice. So our first one, all 90-degree angles are right angles. So of course we need to start with the word if, and we need to determine which is what the hypothesis should be. So we're saying 90-degree angles are right angles. So we would say if an angle is 90 degrees, we'll put our then, And our conclusion would be, if an angle is 90 degrees, then our conclusion should be it is a right angle. So the original statement had a conditional feel to it. It means if an angle has 90 degrees, it's a right angle. We've just put it in the conditional form. And again, an angle is 90 degrees is our P. It is a right angle is our Q. So if we were to write it in symbols. We can do the same thing here. If. So our statement is when n equals 9, n squared equals 81. This one's really easy. All we have to do is pop the if and then in there. So if n equals 9, then n squared equals 81. So n equals 9 is our hypothesis, n squared equals 81 is our conclusion. So if we were to do symbols again, there's a P and a Q. So go ahead and pause. Try this third one on your own. It's very similar to the one we just did. So you should start with an if. It's always an easy place to start. And this first part is our hypothesis. If 2x plus 7 equals 1, then x equals negative 3. So if this is true, if this 2x plus 7 equals negative 1 is true, then that means x was negative 3. Again, just going to keep showing this. Our conclusion we usually call Q. Our hypothesis we usually call P. And we'll get to using those a little bit more later. Sometimes we want to negate a statement when we're dealing with logic. So these are basic statements down here, and we're going to be using this negation in some conditional statements. So a negation is kind of what it sounds like. It's just the opposite. So if we have an original statement, the ball is red, the negation would be made just by simply adding the word not. The ball is not red. If our original statement contains the word not, then the negation is just the opposite. We just take that word not out. So originally this was the cat is not black. If we negate that, the cat is black. So kind of a simple idea here. And we're going to use this when we talk about some other types of conditional statements next. So our original conditional statements are if-then statements. We can write symbolically if P, then Q, or P implies Q. Now we might want to take those statements and move them around a little bit. The converse of any statement, any if-then statement, is just taking the Q and taking the P and switching their order. So the converse of any statement would be taking the conclusion, putting it first, and putting the hypothesis at the end. So now we would say if Q, then P. If we want to take the inverse of a conditional statement, we would just negate the hypothesis and the conclusion. So back to our original if P, then Q. If we want to write the inverse of if P, then Q, we would write not P, then not Q. And the way to do not is by doing a little squiggly, kind of like the similar symbol. So not P, not Q. That's the inverse. And it's going to be important to know these in symbolic form and how to write them when we get to some words, which we'll do next. The last kind of conditional statement we'll use is called a contrapositive. So if we go again back to if P, then Q, we're going to do both the converse and the inverse, and that will give us what we call the contrapositive. So we switch the order. Q comes first, P comes second, and we negate them. So the contrapositive is, if not Q, then not P. An important thing to note here is that the contrapositive of any conditional statement is always either, if the conditional statement is true, then the contrapositive is true. If the conditional statement is false, the contrapositive is false. So we say that they are logically equivalent. So we might ask you to write a statement logically equivalent to a conditional statement, and what we're really asking for is for you to write the contrapositive. So let's practice that a bit. We have a conditional statement here. If you are a guitar player, then you are a musician. It's always important to first figure out what the hypothesis is, so what our P is. P is you are a guitar player. Our conclusion, or our Q, is you are a musician. So if we want to write the converse, we have to switch P and Q. So we're still going to have if, but now we're going to write you are a musician. So we're going to write Q first. We'll have our then. And we take our P, our original hypothesis, and we put it at the end this time. You are a guitar player. So you can see all we did to write the converse of our original statement was to switch you are a guitar player and you are a musician in the sentence. To do the inverse, we're going to keep them in the same location. So you are a guitar player is going to stay in the same spot. You are a musician is going to stay in the same spot it originally was. And we're just going to negate those statements. So the negation of you are a guitar player would be you are not a guitar player. And we'll negate you are a musician. The negation of that becomes you are not a musician. So again, we kept the original statements where they were, the original hypothesis conclusion. All we did was negate each of them. And the last conditional we're going to do is the contrapositive, and that's doing the converse and the inverse. So we'll switch P and Q, and we will make them negated. So we've already got a start here. We've got the inverse where they're negated. All we need to do is switch the order. So we can write if you are not a musician, then you are not a guitar player. So, little tip, like I said, always find the P and the Q when we want to write these of the original statement. And you have to know, and it's good to know, that the converse is Q implies P, so you would know just to switch those two. The inverse is not P implies not Q, and the contrapositive not Q implies not P. So if you find P and Q and you know the symbolic forms of these three related conditional statements, it's pretty easy just to move the pieces around and write your new statements. So I have a U-try for you. There's three. Starting with the original statement, if a polygon is an equilateral, then the polygon is regular. Determine the hypothesis conclusion, and then write those three related conditionals. And last, I want you to write that statement that's not in if-then form but is a conditional statement. I want you to write that in if-then form as a condition.